Given two numbers in base 10, we can easily determine which one's greater by comparing their digits. However, comparing fractions is much more complicated. Every fraction is equal to infinitely many other fractions, so we can't always just tell by comparing digits. So in this video, I want to talk about how to compare fractions using common denominators. When two fractions have the same denominator, we can compare whether they're equal or not, or which is greater, by comparing the numerators. As an example, let's look at 4/7 and 3/7. Both fractions are described in terms of like parts, in particular sevenths. So we only have to see which one has more parts. We can see this has 4 parts, whereas this one over here has 3 parts. So that tells us that the 4 is greater. To use the visual, here I have 2 bars that are each broken up into sevenths. One has 4, while the other one has 3 parts. So we can see that this one has more total shaded. So we have more of this bar than we do of this bar. So 4/7 would be greater than 3/7. However, what if we want to compare two fractions that don't have the same denominator? How can we find out if they're equal or which one's greater? One way to do this is using a common denominator. It can be any common denominator, it doesn't have to be the least one. And a common denominator that always works is obtained by multiplying the two denominators. As an example, let's consider 3/4 and 5/6. For 3/4, we want to multiply by 6 since that is the denominator of the other fraction. 3 times 6 is 18. 4 times 6 is 24. For 5/6, we want to multiply by 4 since 4 is the denominator of the other fraction. 5 times 4 is 20. 6 times 4 is 24. So we can see that 20/24 is greater than 18/24. So the 5/6 is the greater of these two. So 5/6 is greater than 3/4. And we would reach this exact same conclusion by using a common denominator of 12 instead of 24. So it doesn't have to be the least common denominator as long as it's any common denominator. And like I said, if you're having trouble, just multiply by the denominator of the other fraction. And what we're really doing when we give two fractions common denominators in order to compare them, well, we're creating like parts. Once the fractions are described in terms of like parts, we only have to see how many of those parts each fraction is made of. So there is another way to do this without directly getting common denominators, which is cross-multiplying. In the previous example, when we looked at 3/4, we multiplied by 6 to get 18/24. And we looked at 5/6, we multiplied by 4 to get 20/24. So really all we were comparing was the numerators. All we really needed to see was 3 times 6 and 5 times 4 and determine which one of those is bigger. And so really all we had to do was multiply the numerator of each fraction by the denominator of the other fraction and compare those two results. And this is known as cross-multiplying, and it's just a shortcut of this idea of common denominators. To do 3/4 and 5/6, well, we multiply this way. 3 times 6 is 18. 4 times 5 is 20, and we know 20 is greater. So that tells me that 5/6 is greater than 3/4. So this is just a shortcut way of using these common denominators.